calculate the exact value of. And part 1 gives us, it says 5.8 square plus 1.02 multiplied by 2.5. So what we do know is that from the Bombas theory using operations, we always work out our brackets first. So it's always a bracket of multiplication, division, addition, and subtraction. In this case, there is a bracket, so we will work our brackets first. But within our bracket is another operation, which is the square, which is 5.8 being squared. So what I'm going to suggest that we do is to work out our square first. So what we'll have is 5.8, so let me just rewrite the question first. So it is 5.8 square plus 1.02, and that is multiplied by 2.5. So as I said, we will work our bracket first, but before in our brackets, what we will work first is the 5.8 square. So it will be 5.8 square, and 5.8 square, when you put that in your calculator, what you'll get is 33.64, and we put back all our other terms that was given in the expression, which is 1.02 in bracket multiplied by 2.5. So now I'm going to work my bracket. So what I'll have is 33.64 plus 1.02, and that will give me 34.66. So I have 33.64 plus 1.02, that will give me 34.66, and it is 34.66 that I am multiplying by 2.5. Now, should you put in your calculator 34.66 multiplied by 2.5, what you will now get is 86.65. And this is our answer in its exact form. So it is 86.65. But just for a bit of mischievousness, if they had asked us to write this to one decimal place, who can tell me what my answer would have been?
86.7.
Very good. And that is this written to one decimal place. If I was writing this to two significant figures, what would my answer have been?
87.
That is correct. 87. So if my answer has been written to two significant figures, it would have been 87. Now, part 2 asked us to work a fraction. So they gave us, so we have 2 and 4 over 9, and that is divided by 4 and 2 over 3 minus 3 over 7. So what I'm going to do first is to work the first fraction here that is given, which is the 2 and 4 over 9 divided by 4 and 2 over 3. So that will look like 2 and 4 over 9 divided by 4 and 2 over 3 minus 3 over 7. So what I'll do is I'll put a bracket around the first two concepts that I will be working first, or the first two fractions, which would be the 2 and 4 over 9 divided by 4 and 2 over 3. So what I'm going to do first is to change these mixed fractions to improper fractions. So from this first term, I'll do 2 multiplied by 9 to give me 18 plus 4, and that will give me 22 over 9 divided by 3 times 4 is 12 plus 2 will give me 14 over 3, and then I'll subtract my 3 over 7. But there's something very unique about dividing fractions. Never divide fractions straight. So we write back our first term, which in this case is 22 over 9. We change our division sign to a multiplication and then flip the fraction that follows, which is reciprocate the fraction that follows. So now what I'll have is 3 over 14. And still carrying our minus 3 over 7. So when I reach at this point, what I can do is do some amount of simplifying. So I can do 3 into itself goes 1 time, and then 3 into 9 goes 3 times. I can do 2 into 14 goes 7 times, and I can say 2 into 22 goes 11 times. Everybody with me so far?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So now from this, what I'll have is 11 multiplied by 1 to give me 11, and 3 multiplied by 7 to give me 21 minus now my 3 over 7. That is also remaining, and we are good so far. So now what will be the next step in solving this fraction?
Finding the
highest.
The highest? The
LCM.
LCM. And what will be my LCM?
21, sir.
21. That is correct. Will be 21. So what I'll say is 21 into 21 goes 1 time, and then 1 multiplied by 11 to give me 11, and then put my minus sign. Then 7 into 21 goes 3 times, and 3 multiplied by 3 will give me 9. And now what I can say is 11 minus 9 will give me 2 over 21, and believe it or not, this is my answer. So my answer is 2 over 21. So now we are moving to part B, and it says a company pays its employees a basic wage of $9.50 per hour for a 40-hour week. Part 1 says calculate the basic weekly wage for one employee. So can anybody give me an idea of how I would work this one? The first person to start speaking will take the floor.
You're going to multiply the hours, how much for the hours by the amount of hours worked.
So we know that the basic wage is $9.50 per hour, and we know that the total hour in any given week, even the total hours that can be worked in a given week, is 40 hours. So therefore, to calculate basic weekly wage, that would be the basic wage per hour multiplied by basic wage per hour multiplied by number of hours in a basic week. So what that would give me is basic wage is equal to the basic wage per hour. The question told us is $9.50, and that is being multiplied by the number of hours that can work in a basic week, and that would give me 40 hours. So when I multiply that, what I will get for basic wage, which the question asks us, calculate the basic weekly wage for one employee, that would be equal to $380. And it is as simple as that. So basic wage for one weekly employee, for basic wage for 1 week for an employee will be the basic wage per hour multiplied by the number of hours that can work, and that would be $9.50 per hour multiplied by 40 hours, and the per hour will be cancelled with the hour, and that will leave us with only a dollar amount of $380 being the basic weekly wage for one employee. So part 2 now says overtime is paid at a rate of time and a half. Calculate the overtime wage for an employee who works 6 hours overtime in a certain week. So who wants to take that one?
Sirs, good night. So you're going to get the rate per hour and add half of that rate to it and times it by the amount of overtime.
You'll add half the amount of the regular basic wage, and by that you'll multiply by the overtime amount. But what I'm going to do is say overtime is equal, so they say we're calculating overtime at time and a half. So I'm just going to do overtime, which is time and a half, multiply by the basic wage per hour. And when I do that, what I'll get is overtime is equal to 1.5 multiplied by $9.50. And that means my overtime rate will be equal to $14.25, which is just finding a half of $9.50, which is the basic wage per hour, and you add that half amount to the basic wage per hour, and you will get the same $14.25. I just go ahead by saying multiply 1.5, which is time and a half, by the basic wage per hour, and you get the overtime amount. Then he went ahead to say, so therefore for anyone who works 6 hours in overtime, which is what the question is asked us, they will be paid. So therefore 6 hours in overtime will be equal to 6 multiplied by the overtime rate of $14.25 per hour, and that will give me $85.50. So should someone work 6 hours in overtime, they will get $85.50. So then the question went on to say, in a certain week, the company paid its 30 employees a total of $12,084 in basic and overtime wages. Calculate for that week the total paid in overtime wages. So it is saying in a given week, they had paid 30 employees, and for the 30 employees they paid a total of $12,084 in basic and overtime wages. So calculate for that week the total paid in overtime wages. What we do know from what we calculated in part 1 is the amount that is paid for basic wages, and this amount does not include any overtime, which is $380. So we know how to calculate for 30 employees, which we're assuming that they all worked 40 hours in this given week, what would be the total basic wage for these 30 employees. When we get that amount, we will now subtract that from the total amount that was paid from this company, which is $12,084, and whatever that remains will be considered to be overtime wage. So let me just show you exactly what I am saying. So total hours, total number of overtime hours worked. So what we're saying is basic weekly wage of one employee is equal to $380. We calculated that in part 1, so we know it's true. So therefore, basic weekly wage of 30 employees is equal to then $380 multiplied by 30. And when you do that, what you will get is 11,400. So I'm assuming that we have 30 employees and they all worked 40 hours per week. What we're saying is that what that basic wage would have been is 11,400 if none of our employees had worked overtime. But however, the question said 30 employees and somehow they had also paid overtime amount. So therefore, overtime, total overtime will then be equal to the total paid subtracted from total basic wage. And that would give me, so total overtime is then equal to $12,084 minus the total basic wage, which is 11,400. And when you do that calculation, what you will get is $684 being the total amount that was paid in overtime wages. So now part 4 asks us to say calculate the total number of overtime hours worked by employees. So total overtime hours worked by employees. So what we know is that 1 hour of overtime is equal to $14.25, which is what we've calculated. So therefore, we're trying to find X hours. How many hours in overtime is worked from this set of 30 employees? So X hours is therefore equal to $684. So therefore, to find the total amount of hours, overtime hours that worked by these employees, all we'll need to do is to divide the total amount of overtime hours that was paid out, total amount of overtime money that was paid out, by what is the equivalent of 1 overtime hour. So therefore, X hours is equal to $684 divided by $14.25. And when you do that calculation, what you will get is 48 hours. So therefore, the total amount of overtime hours worked by employees in this given specific week is 48 hours. How do we know that our answer is correct? It will be the same as if the question had asked you, if the employees worked 48 hours in overtime, what would have been the amount that is paid out by the company? All you would have done was to say 48 multiplied by $14.25, because we know that it is $14.25 is the overtime rate, and you'll get the $684, which is what we're trying to find. So therefore, if we're now doing the reverse of that calculation to find if instead they gave us the dollar amount, how can we find the total amount of hours that was worked? So if before we multiplied to get the dollar amount, to get the hours that is worked, all we need to do is to divide the dollar amount of $684 by $14.25, and you'll get the total amount of hours that is worked.
Yes.
So part 2 now says simplify, and they gave us an expression, and they said express your answer as a single fraction. So what we have is 2x over 5 minus x over 3. Who can tell me what I will do first?
And the LCM.
Find the LCM. 15 is my LCM. And therefore, what I'll say is 5 into 15 goes 3 times. And what we usually do is to multiply this 3 by the numerator. But instead of writing it down, I am going to go ahead and write it here and say 3x. We put our subtraction sign, and now we say 3 into 15 goes 5 times, and now we're going to multiply 5 by x. And now we can go ahead and work out our numerator portion. So it will be it will be 3 multiplied by 2x to give me 6x, and then 5 multiplied by x to give me 5x. That's basically be 1x over 15, which is the same as x over 15, and that is my answer being expressed as a single fraction. So now we are moving on to part B, which says factorize completely. And if anybody understands factorization, it probably should be one of your most interesting topics. And it will be, so basically when you're doing factorization, you're looking for what is the common element in this given, for example, this particular example, you're looking for what is the common element in the given terms in the question. So when you find what is the common element, it goes on the outside, and then whatever is you're going to now use this common element to divide into each term, and the resulting answer will go in a bracket. And as you can see, this one should be easy as it is only 1 mark. So what we have is a square b plus 2ab. So what is my common element? What is my common factor? What is common from these 2 terms?
AB.
Very good. AB is correct, and it is AB that I'm going to use to divide into each term. So I'm having AB on the outside, and I'm going to say AB into a square b, and what will that leave me with?
AB.
A.
No, A.
A. Thank you.
A.
That's AB. So it will leave me with A. And now I have AB into a positive 2AB, and what will that leave me with?
2.
2.
2. So therefore, my answer is AB outside and in bracket A plus 2. And believe it or not, that is my answer. And we leave it and we take it and do not.
Sir, I don't understand this one.
Okay, don't understand this one. So with factorization, this is simple factorization. So what we're looking at always is what is common in the given expression. So we're looking at, so basically what they gave us is A multiplied by AB plus 2 multiplied by AB. So when we're looking at the concept of factorization, and when it also includes letters, basically every term within the expression should come, once it is common to both terms, it should be a part of what is considered to be the common factor. So in this case, A is common to both terms and B is common to both terms. The number 2 isn't common to both terms. The number 2 is only in the second term. So for example, if instead of A square B plus 2AB, if they had given us, let's say, A square B plus 2ABC, our common factor would have still been AB, because A and B are the only terms that are in both parts of the expression. C is not in the first term. C is only in the second term. If the first term was A squared BD, our common factor would have still been AB, because D is only in the first term, but it is not a part of the second term. So basically, when you're looking at factorization, the term that goes on the outside, which is used as the divisor into each term, must be common to every single term which is in the expression. So if they're giving you that and then say plus 2BC, this is just an example, and if they're given this and said 2BC, what would have been my common factor from this expression?
B only.
B only, because B is the only term that is in every term that is given. So B was in the first one, B was in the second one, and B was in the third one. So B would have been my common factor. However, from this example now, what we're seeing is that A and B are the only variables, whatever you want to call it, that is repeated in each term. So it is considered to be my common factor. So with it being considered to be my common factor, it goes on the outside, and I'm going to use it to divide into each term that the examiner gives us. So I'm going to say AB into A squared B, which, now let me break that down. So what that is basically saying is, so this is what we're doing. A, which is A squared, so it's 2A, and then a B. And what we're saying is all of this is divided by the common factor, and our common factor was AB. So yes, guys, so what I was saying was we're using the common factor to go into each term. So it is the A squared B, and we're dividing the A squared B by the common factor. So basically what we're doing is some amount of division, which is what you've used to. So what I did was to say A from the bottom, the denominator cancel with one of the A up top, and then the B is cancelled with the B up top. So all we have remaining is this single solitary A up here, and this A that is up top is what was in the first term in our bracket, and that is what I also will put here in rewriting the answer. And then it's the same AB I am now going to divide into 2AB, so it will be 2AB divided by AB, and we can see that simple division, which it will both cancel the AB from the numerator with the AB from the denominator and leave me with a positive 2. And once again, this is my answer. So my answer is AB outside, which is my common factor, and in bracket, whatever that remains, which is A plus 2. So we're good, everybody?
Yes, sir.
Yes, sir.
Okay, very good. So now we are going on to part, wait, no. So now we have part C, which states express P as the subject of the form. So what we have is P squared minus R divided by T. So what we have is now making P the subject of the formula. So what we learned is that we always move the variables that are furthest apart from P, so things that are not attached to it. So in this case, the first variable that is not attached to P in any way, shape, or form is our T, which is dividing on our right hand side. So basically what we're going to do is to multiply both sides of this equation by t, which is the same as moving the t from the bottom part to bring it up top beside the q. And what the famous thing is, if whatever the variable or the whatever operation is performing on one side of your equation, whenever it crosses the equal sign, it will be doing the opposite. So in this case, the t was dividing on the right hand side. When it goes across the equal sign, it will be multiplying. If it was adding on the right, when it goes on the left, it will be subtracting. If it was subtracting on the right, when it goes across the equal sign to the left, it would have been adding. So you're always doing the opposite. You're always performing the opposite operation on whatever variable that you are using once it crosses the equal sign. So there are multiple ways to look at this. My favorite way is just to say I'm moving the t from the right, putting it to the left. It was dividing, so when I bring it across, it will now be multiplying. So what I'll have is q multiplied by t is equal to p squared minus r. Now I'm going to move the r. So I'm basically adding r to both sides of the equation, or the same thing as I'm moving a negative r from the right hand side and I'm putting it to the left hand side. So what I'll now have is qt plus r. So the r was subtracting on the right. When it comes across, it will be adding. So I'll have qt plus r is equal to p squared. And now the opposite of square, who can tell me what that is?
Square root.
Square root. So therefore, to get rid of the square that is under p, I will need to square root both sides of my equation. So it becomes the square root of qt plus r is, okay, so the square root of qt plus r is equal to p. And believe it or not, that is how simple it is, and you get your 3 marks, and that is my answer. Any questions?
No.
Okay, so I'll take
No, sir.
No, sir, you make it look simple.
So in a simple one.
Yes, sir. You're making it look simple.
So that's, someone said I should scroll on. So that is my answer, which is qt plus r is equal to p. So part D now says the student in a class sell donuts to raise money for their school project. The donuts are sold in small and large boxes. The number of donuts in each type of box is given in the table below. So they're telling us that in a small box contains X amount of donuts. And in a large box contains 2x plus 3 amount of donuts. So it says the student sold 8 small boxes and 5 large boxes in all, and part 1 requires us to write an expression in terms of x to represent the total number of donuts. So what they told us is that 8 small boxes, and in each box with each containing x. So if I have 8 small boxes and each box contain X amount of donuts, what would I use to get the total amount of donuts in my small boxes? What would
8 plus x. 8 times x.
8 times x.
That is correct. It will be 8 times x. So it is like saying if there are 2 donuts in each box, how would I know if I have 8 small boxes, how many donuts would I have in all? I cannot say 8 plus 2, because that would only give me 10, and you'll rob yourself if you're out on the street selling. Instead, you'll need to say the 8 boxes that I have, and with each box containing 2 donuts, I'll say 8 multiplied by 2 to give me 16. It is a similar concept. So what I'll have is 8 multiplied by x, which would be 8x. And if I have 5 large boxes with each containing 2x plus 3 amount of donuts, what would my total number of donuts be in my large boxes?
10x plus
10x plus
15.
3.
Yeah. 10x plus what?
3.
15.
Plus 15. Plus
15. So it will be 5 multiplied by 2x plus 3. And when you expand that, basically using the distributive law, if you don't remember what distributive law is, it's a good time to write it down and check up on it. So it will be doing 5 multiplied by 2x, which will give me 10x, and 5 multiplied by a positive 3, which will give me 15. And for those who did not see, that is how the students got 10x plus 15. Now, all I am doing is now writing my expression in terms of x to represent the total number of donuts that was sold. So I have 8 small boxes that was sold, which gave me 8x plus the amount of donuts that I sold from my large boxes, which would be 10x plus 15, and that is the total number of donuts sold. Do I leave my answer as that?
No, sir, because you have 2 terms where you have a same 2 terms that have the x similar coefficients, sir, so you can add them, group them.
Very good. That is exactly it. So I have 2 x's which are like terms. So all I'm going to do is to add my like terms. So I'll say 8x plus 10x, and that will give me 18x plus 15, which would give me my total donuts. And that is my expression, and that is how I will get my 2 marks. So now part 2 now says the total number of donuts sold was 195. So calculate the number of donuts in part A, a small box. So if the total number of donuts that was sold is 195, calculate the total number of donuts in a small box. So they're telling us that from up top are 18 plus x plus 15. 18x plus 15 is equal to 195. So the total donuts is replaced by 195 because now they told us what the total donuts sold is. So does anyone can tell me what my small box is?
Sir, you're going to solve for it.
Very good. I am going to solve for the famous x. So we're going to solve for x. So that means what I will have is, so in solving for x, I am basically subtracting 15 from both sides of the equation, which is basically removing it from the left hand side to the right hand side. It was adding on the left, so when I put it to the right, it will be subtracting. It crosses the equal sign, the sign of the operation changes from addition to subtraction. So now what I will have is 18x is equal to 180. Again, now I'm moving the 18 from beside the x. So what I will have is x is equal to 180 divided by 18. My 18 was multiplying on the left. So when it comes across to the right hand side, it will be dividing. And what I'll have is 180 divided by 18 will give me 10. And that is my value for x. So now in solving part A, it says what is the number of donuts that is in a small box. Mills, is that x being 10 or x being the amount of donuts that was sold in a small box?
Sorry, small box.
Ah, very good. So coincidentally, in this case, x, which we found, is also equal to the amount that is in the small box. As if you remember from our table, it told us that in each box, the number of donuts in a small box is x. So therefore, for a small box, it will also be 10 donuts. A small box contains 10 donuts. So part B asks us for the number of donuts in a large box. So what would be the number of donuts in a large box?
So you're going to substitute the 10 in the 2x plus 3, sir.
Bright people in other classes. So now it will be large box is equal to 2x plus 3. And as she rightfully said, we know what the value for x is. So now we're going to do substitution. Substitution in algebra. This is a part of the syllabus. So it will be 2 multiplied by 10 plus 3. And 2 times 10 is 20. So it becomes 20 plus 3 and 20 plus 3, 23. So in a large box contains 23 donuts. So part 3 now says, question 3a says, simplify the expression. So they gave us 7p to the 5th power, q to the 3rd power, multiplied by 2 multiplied by p squared q. So this is in line with the laws of indices. So for those who don't know, what you'll do is you can basically break this expression apart, work the coefficients meaning the numbers by themselves, then working the variables, the p's and the q's by themselves. And that is exactly what I'll do, and then put everything together. So working the coefficients, what I'll have is 7 multiplied by 2, and we all know our 2 times table, that would give us 14. And now we will have p to the 5th power multiplied by p to the 2nd power, p squared. So for those who don't know, in looking at laws of indices, when you're multiplying powers that contain the same base, you're basically adding the indices, adding the powers. So it will be basically adding the indices. So it is p and 5 plus 2, which is 5 to the 7th power for the p's. For the q's now, it will be q to the 3rd power multiplied by q by itself, which is basically q being raised to 1 power. And for those who don't know, any number at all raised to the 1st power is itself, and any number raised to the 0 power is always 1. That's just a bit of extra information. So this now will be q raised to the 3 plus 1, which will work out to be q to the 4th power, and therefore my answer will be, now I'm putting everything together. What I'll have is the number 14, I have p raised to the 7th power, and the q raised to the 4th power. So what I did was just to break them apart, work them separately, and then in the end put everything together. So I work my coefficients, work my p's, work my q's, now put everything together, and we get a perfect answer and get our 2 marks. So we just looked at law of indices and also which is under multiplying powers. If we're, however, dividing, when under law of indices, when you're dividing bases or powers which have the same base, it's the opposite, which is basically subtracting the powers. Is everybody still with me after 55 minutes here in my
Yes, sir.
Okay, very good. So it is good that no one has fallen asleep. Do we need to segregate them to get full? You do not need to segregate them. That is just my way of ensuring that you understand exactly what we're doing. So instead of just writing back 14p to the 7, q to the 4, I'm showing you the process of how we would have arrived at that answer by just breaking them apart. just trying to make math fun and easy to show you that it is not always a terror, or that it doesn't remind us of any of our x's.
Period.
And we're now going on to part B. So it says Fresh Farms Dairy sells milk in cartons in the shape of a cuboid with internal dimensions 6 centimeter by 4 centimeter by 10 centimeter. Calculate in centimeter cube the volume of milk in each carton. Does anyone have an idea of how we will work this? The good thing about measurement is,
N times width times height.
and the very good thing about measurement, the section called measurement, is that CXC tend to be very generous, and whichever question they usually ask, and once it requires a formula, they tend to put it at the front of the booklet, multiplying the dimensions, which would be length times width times height. So it is length multiplied by width multiplied by height. So my volume would then be 6 multiplied by with a 4 multiplied by my height of 10 centimeter.
$240,
That is correct. So my answer is 240 centimeter cubes. That is 6 multiplied by 4 multiplied by 10. And all of them said, that's so easy. Yes, that is exactly how easy it is. So what we'll get is 240 centimeter cube to be my volume, and we easily get our 2 marks right there and then. Always remember your units are very important to the examiner, to the marker. So are we good?
Yes, sir.
Okay, good. So part 2 now says a recipe for making ice cream requires 3 liters of milk. How many cartons of milk should be bought to make the ice cream? So what we know is that 1 liter is equal to 3,000 centimeter cube. As we know, we can never work mathematics with 2 different units, so I cannot use a liter and a centimeter cube that we were using before. So that is definitely a no-no. So this should be 1 liter is equal to 1,000 centimeter cube. So therefore, the 3 liters of milk that they're making reference to, the 3 liters is 3 multiplied by 1,000, which will give me 3,000 centimeter cube. So that is what I actually meant to write. So when they said how many cartons of milk should be used to make this ice cream, so what we know before is that 1 carton contains 240 centimeter cube. So if 1 carton contains 240 centimeter cube, but we need a total of 3,000 centimeter cube of milk to make the ice cream, how will I know how many cartons to use to make the ice cream?
So
Divide.
by
My air divide, my air multiply. Which one is it?
multiply.
Multiply.
Sir, I'll say divide.
Indeed, we will divide. Please do not go on the exam and multiply. We can't afford to give back CXC some well-deserved marks. So it is 3,000 centimeter cube divided by 240 centimeter cube, which is what we've calculated up top. And when I do that, what will I get?
12.5.
12.5 cartons. So can I go to the shop? Can I go to the supermarket or the corner store and buy 12.5 cartons of milk?
No, sir, you have to go wrong.
Okay, so therefore it will be approximately 13 cartons, because you cannot go to the supermarket and take a bag and throw out half of the box and say probably somebody else will come for the next half. So you just have to buy the 13, and the next half that remains you can probably give it to your child or your little brother or something. And this is exactly how you'll get your 3 marks in deciding how many cartons of milk should be bought to make the ice cream. Does everyone understand?
When you have that in that idea,
Yes, sir.
Alright.
Sir, can you please go back to part one for this same thing?
Part 1?
Yeah, because my internet was here right here.
Okay. So basically, what I'm doing is finding the volume in each carton, and the formula for volume of a cuboid is volume is equal to length multiplied by width multiplied by height. And what we know is that they gave us all 3 dimensions. So it is now basically just substituting each value into the formula. So our length of the cuboid, which is the carton, is 6, or width being 4 centimeter, and our height, which is illustrated here, is 10 centimeter. And basically, when you do that calculation of saying 6 multiplied by 4 multiplied by 10, what you'll get is 240 centimeter cube to be our volume of each milk in a carton. Understand?
Yes, sir. And one more thing, you think it's necessary for us to memorize the formulas because they bring it on the paper?
No, so that's what I'm saying. There's no need to memorize usually formulas for measurement as are usually given at the front of the booklet. What is important is that you know how to use the formulas, because the thing is, the formulas can be given, but you don't know how to use them because students don't know. You're going on the front and you're skipping. And you're like, wait, which formula should I use here? And that is why it's important that you practice. Oh yeah, I was going to work this one a different way, which is by method of a unitary method, basically. So what I'm saying is, if one carton is equal to 240 centimeter cube, we are trying to find how much carton is needed to make the ice cream, which is X carton is equal to the 3000 centimeter cube. So what I'm basically going to do here is to cross multiply and solve for X. So cross multiply, I have X multiplied by 240. So it is X multiplied by 240 centimeter cube is equal to 300 centimeter cube multiplied by 1 carton. So it is 1 multiplied by 3000. And once again, as we always know, now we're going to solve for X. So therefore, X is equal to 1 times 3000 will give us 3000, and that will be divided by the 240, which will give us the 12.5 cartons. And as we just said, we cannot go to the store and buy 12.5 cartons, so we'll buy approximately 13 boxes. Okay, so part 3 now says 1 carton of milk is poured into a cylindrical cup of internal diameter 5 centimeter. What is the height of milk in the cup? Give your answer to 3 significant figures. So now we're changing shape. It was in a square, which is a box, the box of milk. But now we're pouring this same carton of milk into a cylindrical cup, something more circular, of internal diameter 5 centimeter. What is the height of the formulas are at the front? Do we need to memorize them? No, but you know to need to use them. So now the formula for volume of a cylindrical shape is volume is equal to pi r square h. So it is pi r square h. And that will be, they told us to use pi to be 3.14. So volume is equal to 3.14, which is pi. What is my radius?
2.5.
2.5. We get 2.5.
The diameter is half.
Okay, very good. The diameter, radius is half of the diameter. So it is 2.5 square multiplied by h, which is what we are trying to find. Can anybody tell me what my volume is?
240.
240. The 240 is from what we worked up top, which is in the carton. It is the same carton of milk is being poured into this cylindrical figure. It doesn't matter what the shape is. It is the same amount of milk. So it is 240 multiply is equal to 3.14 multiplied by 2.5 square. I'm just going to work that out now, and you'll get 6.25 multiply by h, and I am now going to solve for h. Can anybody tell me what h is?
12.22.
12.22. So what we'll have is 240 is equal to 3.14 multiply by 6.25. You'll get 19.625 multiplied by h, which is our height. And what we have is 240 divided by 19.625. So it was multiplying on the right hand side. When it comes across, it will be dividing is equal to h, or height. And when you do that, your exact answer will be 12.229 is equal to our height. Is that my final answer?
No, sir.
What is my final answer?
12.2.
12.2. So it is indeed 12.2. So significant figures. Significant figures, you will start counting from the first significant figure on the left, and they have asked us to write it to 3 significant figures. So it will be 1. 1 is our first significant figure, 2 is our second significant figure, and this other 2 behind the decimal point is our third significant figure. So my answer will be 12.2, and this is 3 significant figures. And this is my answer. If I am being mischievous, if they'd asked you to write it to 4 significant figures, what would have been my answer?
12.22.
12.23.
23.
That would have been it to 4 significant figures. Thank you very much. If I only wanted 1 significant figure, writing it to 1 significant figure would have been 1, 0. The thing is, so in this case, what you need is each number that is before the decimal point needs to maintain its base value. So that is why we cannot write 1 by itself, because 1 is in the tens place. So therefore, what we'll need to do is to write back 1, say maintain its 10th position, its tens place position, and then use zeros to fill the other significant places that were there, which in this case would have just been the 1 position. So we'll just put a 0 there to hold its place so that the 1 can maintain its value. And that's just extra lesson brought to you by Prepared for It and the Disha's Online Academy. So part 4 now says, A, the universal set is given as union is equal to all numbers from 1 to 12. So union is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it says H is a subset of U such that H is equal to odd numbers between 4 and 12. And part 1 says list the members of the set H. One person.
5, 7, 9, 11.
Yes, sir.
Okay, that is good. So then it went on to say J is a subset of U such that J is equal to prime numbers. And for those who don't know, odd numbers are numbers that are not evenly divisible by 2. So whenever 2 is divided into these numbers, it always leaves a remainder. So now we're on to part 2, which is list the members of the set J, which is prime numbers.
3, 5, 7.
That's
I'm
it?
not sure if you do 2 and 1. So not too sure.
Anybody want to add
11.
anything?
No,
11.
11. Is that it?
no,
And
sir.
What else?
2.
2. So for definition purposes, prime numbers are numbers that the only factors that they contain are 1
And itself.
That is good. So 1 and itself. And all these numbers are the numbers that only numbers that can divide into them are 1 and itself would be 2, 3, 5, 7, and 11. Please note that the number 1 is not a prime number. And part 3 now asks us to draw a Venn diagram to represent the set U, H, and J, all showing the elements. So let us put on my best drawing skills. Would say I can't draw, but I will
Sir,
say.
it is true, you cannot draw.
So let me prove you wrong. So this is my universal set. And my subsets are H, H. The curfew is affecting me, Lisa, that's why. If there wasn't a curfew, I'm sure these circles would have looked much better. So we have our union here. We have H subset, and we have a J subset. And the what would go here, which is our intersection?
5 and
7 and 11.
11.
5, 7, 11.
5, 7,
7 and 11.
7, and 11.
11.
So in that case, what would go in H? H only.
9.
9.
9. And what would go in J only?
2, 3.
3.
And what would I do with my remaining numbers?
Put it outside.
Outside.
Outside. Okay. So is 1.
Oh, sir.
Huh?
Turn the radio, sir.
Oh. Okay. Okay. Oh, Trace said outside. I think it was out there. Okay. So 1, 4, 6, 8, 10, and 12. So those would go within the union and the outside of the subsets. So yes, if it wasn't a lockdown, I'm sure I've provided better diagrams. But this will work for now, as I'm sure you all understand. So we're good with the Venn diagrams?
Yes, sir.
Yes, sir.
Very good. So now, so part which using a pencil, ruler, and a pair of compass only construct a triangle element with an angle LMN being 60 degrees, MN is 9 centimeter, and LM is 7 centimeter. So what I'm going to do here is to write down exactly what you're going to do, just in case, like myself, you don't have the necessary devices now. So first, what we're going to do is one, draw a line LM. And I'm going to show you a visual afterwards. So after we draw a line LM, we're going to put one point of our compass. So put one point of our compass on the point M. I'm choosing the point M because that is where our angle will be. Since this is an angle LMN with M being in the middle, that means this is where our angle of 60 degrees is being formed. So put one point of our compass on the point M and swerve to cut the line that was drawn, so the line M. So point 3 now. So where after you just made that swerve, where it cuts the line LM, you are going to put your compass and make another swerve to cut the original arc. So this is what that will look like. So we have our line ML. So right here is M. M is here because this is where we're making our 60 degrees construction, and then we are required to construct a 60 degrees angle. We're opening our compass with one point at M to cut our line. So we open our compass to swerve to cut our line. Should make that swerve bigger. So it should be something like that. So when we cut our line, we're now putting our compass at this point where it intersected LM to make another swerve to cut this original arc. When we do that, let's say we do it and we get this. Right here where it intersects, we will then connect M with it to go through, measuring 9 centimeters. So wherever 9 centimeters stop, that is how long your line will be. As it says, M to N should be 9 centimeters. So if 9 centimeters stop here, this is where N is located, and then we can close our triangle to get NL. And what we know is that right here that we just constructed is 60 degrees. And that is what our triangle LMN will look like, with an angle of 60 degrees. Did I lost anyone?
No, you did not. No,
Okay.
sir.
No, sir.
So that is what our construction will look like, a beautifully drawn triangle. So part 2 now says measure and state the angle of MNL. When I did it today, what I got for MNL, which is what you will get when you try it on your own, so you can write this one down, as I cannot measure it on the screen to show you. You should get Okay, so the computer is freezing. Okay, so what you should get your angle MNL to be is 48 degrees. So MNL meaning that you're measuring the angle at N right up here. So MNL is 48 degrees. But now just random question. If angle at M is 60 degrees, the angle at N is 48 degrees, what is my angle at L?
Is it 72?
That is correct, Jamila. 72 degrees. So for those who don't know, angle total degrees in a triangle is equal to 180. So if we know two of the angles, since it is three angles within a triangle, it means that the missing one would just be 180 minus 60 degrees minus 48, and what you'll get is 72, and that will be the angle at L. Yes?
Sir, how did you get the 48 degrees?
Oh, you'll use your protractor. So after you constructed your diagram, you'll use your protractor to get the 48 degrees.
Okay, sir.
So when I did it, that's what I got. And when you did it, once your 60 degrees is constructed properly, you should get the same 48 degrees. But that I cannot show you on the screen now. So part C says, or part 3 says, on the diagram, show the point K such that KLMN is a parallelogram. So what I'm going to write here and then do is important things to note. So part 3. The opposite sides of a parallelogram are equal in length. So with center L, an arc of radius 9 centimeter is drawn, and then with center N, an arc of radius 7 centimeter is drawn. Where the arcs intersect, we will have K. So to explain all of that now graphically, so we have this is the same diagram that we'll be using to construct the parallelogram that the question is asking for. So the first note that I said is that for a parallelogram, the sides are equal. So what we know is that this side is 9 centimeter and this side is 7. So for a parallelogram, it means that the side at the top should also be 7 and the side at the side should be 9 centimeter. So what we're saying is open your compass to 9 centimeter, place it at the point L and make a swing up top. So you're placing your compass, open 9 centimeter to make a swing, a curve up top. So let's say it is like that. And then you're opening your compass 7 centimeter, place it at the point N, to now get the corresponding 7 centimeter from right here. So your compass is at N, you make a swing and you get your point here. Where they intersect is your point K, and that is what I explained down below. Now we can connect. So we're using broken lines to connect. So K to N, and then K to L. And now we have a perfectly drawn parallelogram. So both sides 7 centimeter bottom, 7 centimeter at the top, 9 centimeter at the side, 9 centimeter at the side. So repeating once again, at first we know that all the sides, well, opposite sides on a parallelogram are equal. So at first we open our compass to 9 centimeter to make our first swing, while one point is at the point L. And then second, we change the width of our compass to 7 centimeter, put one point at N, and then swing to get the 7 centimeter. And then where they intersect is our point K. And then we just connect the dots, connect K to N, K to L, and we get our corresponding parallelogram. And they should measure the same length as the sides that were already there. So it's on the diagram, show the point K such that K element is a parallelogram, and we get our 2 marks. Any questions?
No,
No.
sir.
Okay, good. So part 5 now says, the equation of a straight line is given as 3y is equal to 2x minus 6. So it says determine the gradient of the line. So what we know is that the equation of a straight line is usually written as y is equal to mx plus c. What is m?
Gradient.
Gradient. What is c?
Y-intercept.
Y-intercept. So if I'm transposing, well, not fully transposing, but if I'm making y the subject of the formula to represent the formula that is given above, where y is equal to mx plus c, what will be my corresponding value for the gradient, which is m?
2.
2.
Okay. 2.
Alright, so this is
Sir,
what
would it be 2/3?
2 over, this is what it will look like. Y is equal to 2x minus 6, and all of that is divided by 2. So transpose it, divided by 3, sorry. Because I'm moving the 3 from beside the y, it was multiplying. So when it comes across, it will be divided, and we're dividing each term by 3. So therefore, my gradient m is equal to 2 over 3. And that is the gradient of the line. Any questions? So again, our normal equation to represent a straight line is y is equal to mx plus c. M is our gradient, c is our y-intercept. They have given us an equation which is 3y is equal to 2x minus 3. All I did was to make y the subject of the formula to replicate the original equation of what a straight line formula is, which is y is equal to mx plus c. And after doing that, I will get 2x minus 6 over 3. And I just write what my gradient is, which is 2 over 3.
So, sir, the reason we divided it is because y is supposed to be equal to 1, not more than 1. Is that why we divide?
Not y, because y is one of your regular y values from a regular graph, and the same thing for x. But why we divide it is to write the formula. So this equation that they gave us, we're rewriting it in the format of what a straight line equation looks like. So this y equal mx plus c is the guide for what a straight line formula is. So y equal mx plus c is the formula that is used for the straight line of a graph, straight line of a feature, straight line. So y equal mx plus c. So what we're doing is to rewrite this original equation in this format of y equal mx plus c. And then we can accurately get a vision of what the gradient is.
Oh, okay, so thanks.
Okay. And part 2 now asks us the equation of the line which is perpendicular. So we're going to determine the equation of the line which is perpendicular to 3y equal 2x minus 6 and passes through the point 4 and 7. So now what we know is that from the 4 and 7, our x value would be 4 and our y value is 7. This is just something to note information wise. Whenever two numbers are given and in a bracket representing numbers from a graph, the first value is always your x value and the second value is always your y value. This is especially important for when you're doing multiple choice exams. So note briefly, they ask us to find the perpendicular line which we're doing an equation. So please note that perpendicular slopes must be opposite reciprocals of each other. So whenever you're in an exam and see them ask you, hey, find the equation of the line which is perpendicular to this given equation, always know that perpendicular slopes must be opposite reciprocals of each other. So first what we're going to do, which is what we've done already, is to convert the equation to slope intercept. Which will be y is equal to 2x minus 6 over 3. So the old slope, which is another term for gradient, is slope. So the old slope is equal to 2 over 3, which is what we just found out. So therefore, from the first thing stating that perpendicular slopes must be opposite reciprocals of each other, what we know is that the new slope would then be minus 3 over 2. So it is just the reciprocal of the first slope that was given, which means that when we do some amount of multiplication, m1 multiplied by m2, which is m1 is the old slope, multiplied by m2, this is just information purposes, by the way, guys, not what you'll write in exam, it should give us negative 1. And I'm just proving that by saying 2 over 3 multiplied by negative 3 over 2. And if you do some amount of cancelling, you'll have 2 into itself goes 1 time, 2 into itself goes 1 time, 3 into itself goes 1 time, and 3 into itself goes 1 time. And basically what you'll have remaining is this being -1/1, which is equal to -1. As I said, this is just information purposes, just teaching you on the topic as we go along. So now getting to the answers. So with the new slope, use the slope intercept form and the points, which are the points that are given, to calculate the intercept. So what we know is that the equation for a straight line is y is equal to mx plus c and from what was given above, we know that y was 7 because they said the coordinates were 4 and 7. As I stated, the first value is always our x value, the second is our y, so y is equal to 7. Our slope is -3/2 and our x value is 4 plus c. By the way, guys, this now is the answer. This is now what we're working out. So the not only important thing, but what was important up top was to state what the new slope should have been, which should have been the reciprocal of the old slope. So this part is what you'll write on the exam, what your new slope is, which is -3/2, which is just the reciprocal of what your old slope was, which is why they had asked you to find the gradient, which was 2/3. So our new gradient, when we're finding the perpendicular line, will be -3/2, just a flip with a negative sign. And they're giving us the values for the x and y value, which was 4 and 7. The first value in bracket was our x value, the second was our y value, and we're just trying to find what c is, which is the y intercept. So I'm bringing over mine 2, so what I'll have is 2 multiplied by 7 is equal to -3 multiplied by 4 plus c. 2 multiplied by 7 is 14, and -3 multiplied by 12, -3 multiplied by 4 is -12 plus c. And we're now solving for c, so it becomes 14 plus 12 is equal to c, and 14 plus 12 is 26 is equal to c. So now I know what c is. I can rewrite my new equation, which will represent the perpendicular line which will go along with the original perpendicular line which was given. So now what I'll have is 2 multiplied by y is equal to -3x plus 26. And this would have been the same as we know that our gradient is -3/2. It's just that I write back the 2 here to mirror the original equation that was given, which was 3y is equal to 2x minus 6. So again, the parts that are important, determine the equation of the line, which is perpendicular to 3y is equal to 2x minus 6, and passes through the point 4 and 7. First, we'll need to state what our new gradient is, our new slope. And as we know, perpendicular slopes must be the opposite of each other. So this first part here is very important. So what we'll have, this will be on your exam paper, the new slope be -3/2, and after you do that, you're just inputting that into your regular equation for a straight line, So you have your gradient, which is negative 3 over 2, y is 7, x is 4 as given, and you're just solving for what c would have been. We solve for c to get 26, and we rewrite our equation to mirror what our perpendicular line would have been. So now we are on to one of my favorite topics, which is now functions. So it says, does everybody understand what I've done before? Is there any question, any comment, anyone that needs clarification, anything?
Sir, me last.
Oh, Jesus. All right. Let's see if we can do it an easier way. So in our equation of a straight line is y is equal to mx plus c. So we'll start over. We're just stating now what is necessary, not doing the teaching, what is necessary. So it is y is equal to mx plus c, stating our equation of a straight line. And what they had given us to do was to state what is the perpendicular line to the original equation that was given. So we're now determining what is the perpendicular line. So what we're saying is, for perpendicular line, the slopes basically must be the opposite reciprocal of each other. So what we know, Whitney, is that the first slope was 2 over 3. So first what we're going to state is new slope, it must be the opposite reciprocal of each other. So my old slope was 2 over 3. So my new slope will be negative 3 over 2. The complete opposite of what was there before. What was there was a positive 2 over 3. I am doing a flip, sign change, everything. So now I have negative 3 over. So that is what the first thing you're going to write. Equation of a straight line, your new slope. Now remember, the question had stated that this new line that you're going to draw, it passes through the point 4 and 7. So you'll see that right here, passes through the point 4 and 7. So from 4 and 7, what we know is that whenever coordinates are given, the x coordinate is always written first, and so they told us that the coordinates are 4 and 7. So our x coordinates are written first, followed by our y coordinates. So now we're inputting all of this into the equation. So our y value would be 7. So y is equal to m. Our gradient is negative 3 over 2. And our x value is 4 plus c. We don't know what c is, and that is what we're trying to find, which is the y-intercept. So now we're going to solve for c. So what I'm doing is I'm removing the 2 from here to bring it across to the left-hand side. So it was dividing here. So when it comes across, what it will do is to multiply. So what I'll have is 2 multiplied by 7 is equal to negative 3 multiplied by 4 plus c. So we're just now doing only what is essential, what is needed.
One question. How did you get the 7?
So remember, the question state that the new perpendicular line that we're drawing, it passes through the point 4 and 7. So let me go back up. So this is the question. So it said the equation of the line which is perpendicular to this, it passes through the point 4 and 7. So what I was stating is that when coordinates are given, which in this case, these are coordinates, the points 4 and 7, they always write the x coordinate first, which is then followed by the y coordinate. So therefore 4 would be our x and 7 would be our y. Understand?
Yes, sir.
So that is how I got my 7. So I am just now substituting the 4 and 7 into the equation of a straight line, which is y is equal to mx plus c. So 2 multiplied by 7 is 14. And negative 3 multiplied by 4 will give me negative 12 plus c.
C.
Yes. So now I'm solving for C. Am I solving for C? Because C was the only thing in this equation that I did not know. So now it becomes 14
Plus 12
is equal to
equal
C,
to
which is
C.
my y-intercept.
And then you go add, which is 26
So
equals
26 is equal to C. This is now what I'm going to put into my equation of y is equal to mx plus c. But the thing is, I'm not going to write out back the y and x values.
You're going to put in the numbers that you know have found.
I'm not going to put in numbers because I want it to mirror the first line that was given, which the question state is 3y is equal to 2x minus 6. So I want my final answer to mirror this, to state my other perpendicular line. So what I'll have is, so I know what I could have put them in, but I'm allowing it to mirror what was given before. So what I have is 2 multiplied by y is equal to negative 3 multiplied by x plus 26. So it's the same thing as if I had said y is equal to negative 3x plus 26 all being divided by 2. Same thing with my gradient is negative 3 over 2. So it's the same thing, but this is my answer. I'm allowing it to mirror what was originally given. So now we are going on to functions. So it says the arrow diagram below represents the function f of x is mapped onto x squared minus k. And please keep in mind that f of x is the same thing as y. So y is equal to x squared minus k. So our x values are mapped onto y using x squared minus k. They told us that our possible x values are 3, 4, 5, 7, 6, 8, and 9, and 10. So it says calculate the value of k. So
5,
we
sir.
have... Someone is saying something?
Sir, K is 5.
K is 5. Your bright girl Tiana reach way ahead of the class. K is 5. So how Tiana got 5 class is, so remember f of x so f of x, which is given above, is equal to x squared minus k. F of x, which is same thing as y, so we're saying y is equal to x squared minus k. So what I'm going to do is, from my diagram, literally just take any one of these values, but they have to match, and substitute into this equation that was given, which is the f of x is equal to x squared minus k. I am going to take one of my y value, which is equal to my x value. So I'm going to take 4 and 11. So my y value is 11, and my x value is 4. So my y value is 11, my x value is 4. So it becomes 4 squared minus k. And I am now solving for k. So my 4 squared, so 11 is equal to 4 squared is 16 minus k. So my 16 is on my right hand side. it is a positive 16. I'm going to allow it to stay. Since my k is negative, I'm going to bring the k to the left-hand side to make it a positive k. So basically adding k's to both sides of the equation. My 11 on my left-hand side, I'm going to subtract it from both sides, which is the same as saying moving it across the equal sign, it becomes a negative 11. So what I'll have is k is equal to 16 minus 11, and 16 minus 11 is 5. So k is equal to 5. Is there anyone that does not understand? Everyone is okay?
Yes, sir.
Yes, sir.
All right, good. So now Tiana reach a part 2 already too. So part 2 now says, what will be f of 3? So we know f of x from the original formula that is given in the question is x squared minus k. So when they tell you to find f of 3, what they're saying is everywhere in this equation that you see x, you will replace it with 3. So therefore, f of 3, is equal to 3 squared minus k. And we just solved what k is. So k is 5. So we now go ahead and just solve for what f of 3 is. So f of 3 is equal to 3 squared is 9. So it is 9 minus 5. So therefore, f of 3 is equal to 4. So yes, Tiana, f of 3 is indeed 4. Any questions?
No, sir.
No, sir.
All right. So part 3. Part 3 now says we're calculating x when f of x, which is y, is equal to 95. So from our original formula, f of x is equal to x squared minus k, and they're telling us that f of x is 95. So we now need to solve for x. Tiana, give me that one too before we work it.
So you're going to equal the x squared minus 5 to 95, and then you're going to divide both sides, sir, and I'll finish your.
All right.
Sarah can say what I did.
Yes.
I bring over the 5 to get 100 and square both sides to get 10.
Yes.
Very good. So that is exactly how it is done. So my 5 was subtracting here, so I'm going to add it to both sides of the equation, aka move it from the right hand side, it go across equal sign, it will no longer be subtracting, but now it will be adding. So what I'll have is 95 plus 5 is equal to x squared. So 95 plus 5 will give me 100. So 100 is equal to x squared. And now to get rid of square, I will need to square root both sides of the equation. So what I'll have is the square root of 100 is equal to x, and the square root of 100 is 10. So therefore 10 is equal to x. And that is my answer. Anyone that doesn't understand need me to go back over. All right.
Sir, we're good.
All right then. So x is equal to 10.
Sir,
Okay.
sir, I have a question, sir. The only reason why you didn't substitute in the last one where you have if x is supposed to equal to 95, the only reason why I didn't put it in the x squared is because it said x is equal to 95.
It said f of x is equal to 95.
Yes, sir.
At the time, what they're giving you was the value of x. But now they told us that f of x, which is the y, is equal to 95. So we now need to solve what the value of x is. So what value do you input into the x variable to get out an answer of 95? So question 6 says, the line graph below shows the monthly sales in thousands of dollars at a school cafeteria for the period of January to May 2010. So they gave us a nice little graph, sales being given in thousands of dollars from January to May. So it says, copy and complete the table below to show the sales in each month. So who is going to tell me what my sales for February is?
35.
35.
35.
35. Which will be 35,000 because the figures are given in thousands of dollars. What would be my sale for April?
15,000.
15,000, which is what you'll write 50. And we're writing 35 and 15 in the table because they already have the notation here that sales is in thousands of dollars. And what is my sale for May?
10,000.
10,000. And you get your 3 marks right there. So then part 2 says, between which 2 consecutive months was there the greatest decrease in sales? Between which 2 consecutive months was there the greatest decrease in sales? So we now know what February, April, and May is. So which 2 consecutive months was there the greatest decrease in sales?
February to March and March to April.
1 month more. I give me Shamar themselves. So 1 period. So I guess it's either February to March. Okay, so I'm going to use
March to April.
And that can be used by looking at the graph. You can see it has
the line is
the steepest, exactly the steepest decline. But if that isn't obvious to you, probably in the exam you fret and say, how can I ensure that this is correct? What we're going to do now is to say, from the January to February period, we're going to calculate them singly and to see what will that be. In January, there was 38,000 minus February, which was 35,000. So the decline there was basically 3,000. From February to March, what we have is 35,000 minus 27,000, and what we get is 8,000. Everybody following me so far?
Yes, sir.
Yes,
Yes, sir.
Now we have March.
8,000 or it decreased by 8,000?
It decreased by 8,000.
Okay.
So the decrease from February to March was $8,000. So from March to April, March had a sale of 27,000. 27,000, and April only recorded 15,000.
So it decreased by 12,000.
So it decreased by $12,000. And then we have April to May, and April had recorded 15,000, and May is 10,000. So there was just a decrease of $5,000. So from this, we can work out between which 2 consecutive months was there the greatest decrease in sales. That would have been the one with the largest decrease, which would have been March to April. So March to April. And that is my answer. So if you didn't see it on the graph, you see it in the working out. So part 3 now says calculate the mean monthly sales for the period January to May. So what we know for mean or average, it is equal to,
We add up everything and divide by the amount.
exactly. So basically it is the total sales divided by the total number of months. So the total sales will be average. The total sales will be 38,000. So this is 38,000 plus 35,000 plus 27,000 plus 15,000 plus 10,000, and all of that is divided by the 5 months that is being considered, and what you'll get is 125, which is 125,000 divided by 5, and when you do that you will get $25,000 being the average. So part 4 says the total sales for the period January to June was $150,000. Calculate the sales in dollars for the month of June. So for January to May, we had recorded 125,000, which is the total sales. So now an additional month came on, January to June. So what would be the total sales recorded in June? So what the question states is that this 150,000 actually covers the entire period for January to June. So now what we know is that we know the total sales.
Oh, you do the opposite, sir.
Yeah, so we know the total sales from January to May, which was 125,000. So if one more month is added and it moves from 125 to 150, which represents the total sales.
That means that June are equal to 25, sir?
Yup. So January to June, and all they did was to add one extra month, and now we move from 125 to 150,000. It means that what we made in June sales is equal to this total sales from January to June subtracted by the total sales from January to May, which was 125,000. So we have June sales being $25,000. We're good? Everybody good?
Yes, sir.
Yes, sir.
Okay. So part 5 now says comment on how the sales in June compared with the sales in the previous 5 months. So if we look, January we recorded 38,000. February we had recorded 35,000. March we had recorded 27,000. April we had recorded 15,000. May we recorded 10,000, and now in June rain fell, the good Lord was on our side, and we recorded 25,000. So part 5 is asking us, comment on how the sales in June compared to the sales in the previous 5 months. Is there anything that stood out to you in particular? All we want is 2 points.
It was actually a dramatic decrease in sales, or a drastic. Sorry.
Decrease?
There was an increase, sir.
There was an increase at the end of,
Of June.
10, you know. So June and June you had 20%. So there's an increase of 15,000 in a June.
Yeah. So like for the first time in 5 months,
It is a decrease, sir.
increase, because we're moving from 10,000 to now 25,000. So for the first time in 5 months, there has been an increase in sales. Because I realize January comes straight down to May, it has always been decreases. So for the first time in 5 months, we are experiencing an increase. So this is the only month that has shown an increase. Next observation, this 25,000 that was sold in June.
So it's the total of April and May.
Go again, Jamila.
So it's the total of April and May combined.
Well, total of
Sir,
April.
it's also the average amount of
Exactly.
sales.
So that's one. It is the average. It is the same as the average of the past 5 months. Jamila said it is the total of the past 2 months. So what you're seeing again, there's an increase of things that are starting to look better. So it is the only month that showed an increase. It is now also the third highest sale so far in the year. And it is the same as the average or mean sales in the past 5 months. And those are some of the observations that you can write to comment on the sales in June compared with the sales in the previous 5 months. And I think that is the end of our webinar part 1. Next time we see you, we'll be working algebra question, strictly functions, which is the end part of 2011, function relations and graph, vectors and matrices. But it has been an absolute pleasure to be here with you in this lockdown for the past 2.5 hours basically.